Hi there. Now today we have a problem sum in front of us with lots of ratios involved. Okay, so let's dive into the question. At a community center, there were 3 cooking classes A, B, and C. There were 6 more men in class B than in class C, and 6 fewer men in class B than in class A. The ratio of the number of men to the number of women in class A, B, and C were 1:2, 1:3, and 1:5 respectively. All the 3 classes had the same number of participants. How many men were there altogether? Okay, so let's read the question once more. RHMC. So we read the question once more. We highlight important words, underline important words, choose the right method, and check. Okay, so at the community center, there were 3 cooking classes, A, B, and C. There were 6 more men in class B than class C, and 6 fewer men in class B than class A. Right, 6 more men in B than in C, and 6 fewer men in B than in class A. The ratio of number of men to the number of women in class A, B, and C are given respectively. All the 3 classes had the same number of participants. This is a super duper keywords in front of us here. Same number of participants. How many men were there altogether? Right, so from here I can develop for myself 3 sets of ratios as they have given to me for A, B, and C for men is to women. So for a class A, it's 1:2, class B, it's 1:3, and class C is 1:5. Now remember the super duper important keyword, same number of participants. All right. So from these keywords, I know that the total number of participants for A, B, and C, they are all the same. Okay, they are all the same. But if you notice very quickly, the ratio is not the same, because for class A, the total ratio is 3 units, class B is 4, class C is 6. Alright, so I developed for myself a total ratio first. Let me explain why do we do this. Okay, so now when we see that the total number of participants or people or things is the same, we have to make the ratio the same as well, so that we can do a direct comparison. Okay, we can actually tell how many units is man, how many units is woman for A, B, and C. We can compare directly, but we can only do that when the total ratio is the same. And why do we have to do that? Again, because of these super duper important keywords. So between 3, 4, and 6, what's the lowest common multiple? Is actually 12. Okay, so how do I get 12? For the first ratio here, I multiply everything by 4. So men is to women. This now becomes 4:8. For the second one, I multiply everything by 3. 4 times 3 is 12. So 3:9. And for the last one, I multiply everything by 2. So this becomes 2:10. As you can see very clearly, the total now is 12 units for all the 3 classes. Okay, so from here I use the information given in the question. There were 6 fewer men in class B than in class A. So class A had more units of men. More by how many units? 1 unit. Okay, so basically that 1 unit is the same as 6 people. I can confirm this information by looking at the first part of the statement. There were 6 more men in class B than in class C. Let's use a red this time. So as you can see, in class C is lesser number of units, class B is more number of units for men. Okay, the difference is again 1 unit, and again 1 unit is 6 people, because there were 6 more men in class B than in class C. Okay, so the question is how many men were there altogether? All I need to do is to add up all this number of units for the man part, which is 4 plus 3 plus 2, which is going to be having a value of 9 units. So I ask myself, what is 9 units equal to? 9 times 6, that gives me an answer of 54 men in total. Okay, so the technique for this question is to understand that there's this super duper important words here, same number of participants in all the 3 classes. which means that I can make the ratio the same. Once I do that, I can do a direct comparison, and using the statements fewer or more than, okay, I can find the number of units and how many unit, what's the value for that one unit, and from there I find 9 units for the total number of men for this question. Okay,